Welcome to The Explainer. Today, we're diving into the wild journey an AI model takes to get from a nice, clean lab environment into the real world. And let me tell you, it is a trip that involves way more than just hitting run.
So you've done it. You've built an AI model, and it's acing all the tests. It looks perfect. You think the job's pretty much done, right? Well, actually, the hardest part is just about to start. It's called deployment.
And this is that crucial make-or-break moment. Deployment is the bridge that takes a cool experiment and turns it into a tool that people can actually use. But man, is that bridge full of potholes.
So what's the big deal? I mean, we deploy software all the time. What makes pushing an AI model out into the world so much trickier than just updating an app on your phone? Turns out, they're just built different.
This slide really says it all. Traditional software, it's deterministic. You put something in, you get the exact same thing out, every single time. But AI models, they're probabilistic. They're making incredibly smart guesses, which means their answers can change. They need constant babysitting to make sure they're still on track, and they demand some seriously powerful, specialized computer gear to even run. Let's be honest, they're a lot more high maintenance.
To handle all that drama, engineers use some really clever tools. Think of Docker as a perfect little lunchbox for the AI. It packs up the model and every single thing it needs to run into one neat, tidy package. And then Kubernetes is like the master delivery service, making sure that lunchbox gets opened and runs the exact same way, whether it's on a single laptop or spread across 10,000 servers worldwide.
Okay, so before we can even think about sending our model out on its journey, we have to get it in shape. It needs to be smaller, faster, and way more efficient if it's going to survive out there. Let's look at how they pull that off.
One of the most important tricks is called quantization. Now, that sounds super complicated, I know, but the basic idea is actually pretty simple. You're just telling the AI to be a little less of a perfectionist with its math, which lets it think a whole lot faster.
Here's a great way to think about it. It's like taking a gigantic, crystal-clear photo and saving it as a web-friendly JPEG. It's suddenly way smaller, loads in a flash, and you can barely even tell the difference in quality. That's exactly what quantization does for an AI model, and that speed boost is a total game changer.
And it doesn't stop there. There are other slick moves too. Batching is kind of like a carpool for data. You group a bunch of similar requests and process them all at once for max efficiency. And caching? That's like giving the AI a cheat sheet. If it keeps getting the same question, it just remembers the answer instead of having to figure it out from scratch every single time.
All right, section 3, the cloud versus the edge. Our model is slimmed down, packed up, and ready to roll. Now we have to make a huge decision. Where is it actually going to live? And there are two very different paths you can take.
And it all boils down to this fundamental trade-off. You can put it in the cloud, which gives you almost unlimited power and scale. But it can be slow, that's the latency, and you have to think about privacy. The other option is the edge, which means the AI runs right on your device. It's lightning fast and super private, but it's only as strong as the little computer chip in your hand.
You know why Face ID on your phone feels instantaneous? This is why. It's a perfect example of an AI model living on the edge. All the thinking happens right there, on your phone. It's not sending your face to some server halfway across the world, which is why it's so fast and private.
So the model's out there. Job done, right? Not even close. In a lot of ways, the work has just begun. The world doesn't stand still. And if the AI is going to stay useful, it has to change right along with it.
And the single biggest threat to a deployed AI is something called data drift. Think about it. The world today is different from the world a year ago. New slang, new topics, new events. Data drift is when the real world slowly drifts away from the old data the AI was trained on. All of a sudden, its knowledge is stale and it starts making dumb mistakes.
So how do you keep a model updated without, breaking everything for millions of people? You use a safety net called A/B testing. You take the new, smarter model and give it to just a tiny group of users, say 5%. Then you watch the data like a hawk. Is it better? Is it worse? If everything looks good, you slowly roll it out to more people. And if it's a disaster, you just pull it back instantly. No harm, no foul.
Okay, last section. Let's look to the future. With all this complexity, where is the entire field of AI deployment actually headed? Because things are about to get really interesting.
Right now, almost everything we've talked about is done by really smart people working really hard. But we are moving fast toward a future where AI can automatically design even better, more efficient versions of itself. And the ultimate dream? A system that can do this entire, complicated dance all on its own.
And a bunch of new tech is going to pour fuel on that fire. We're talking serverless computing that makes AI way more affordable, like a pay-as-you-go plan, platforms that can manage thousands of different models at the same time, and, of course, custom-built computer chips designed to do one thing: run AI at mind-blowing speeds. It's all about making this technology more powerful and accessible for everyone.
So the grand vision, the holy grail, is a fully automated system. One that can see the world changing, design a new version of itself, test it, optimize it, and roll it out safely, all without a human being lifting a finger.
And that leaves us with a huge question to chew on. As these systems get smart enough to improve and deploy themselves, what is our role in all of that? Does human oversight become the most important safety feature we have, or does it eventually just become the thing that holds progress back?